robots just hit the fast lane, and not in theory, in code, in factories, and even in a half marathon. What used to be a slow grind of scripted demos and one-off prototypes is suddenly a full-blown race across labs, factories, and city streets. Unitree Robotics has gone all in with Reborn, wiring a next-generation training stack called Roboverse straight into its Humanoid. At the same time, Berkeley researchers dropped FastTD3, an open-source reinforcement learning algorithm that trains complex behaviors in just hours, not days. In Beijing, a 1.8-meter biped called Tiankong Ultra made history by finishing a 21-kilometer road race, beating 15 other humanoids that could not go the distance. And on the wheeled front, Shenzhen's Darwin 01 is quietly rolling through warehouses with 12-hour battery life and a foldable humanoid frame. These are not disconnected headlines, they are pieces of a much larger shift where open source code, fast simulation, and modular hardware are all starting to converge. Whether it walks, rolls, or climbs stairs, the next generation of robots is no longer learning in isolation, and the speed of progress is getting harder to ignore. First up, the deal that kicked off the current buzz. Unitree Robotics has inked what both sides call a long-term and significant collaboration with the open-source outfit Reborn. In practical terms, that means Unitree is wiring Reborn's Roboverse stack straight into its production line, starting with the compact G1 humanoid and rolling forward to every future model. The announcement dropped on X with matching threads from both companies and made it clear this is not a marketing handshake. It is an engineering marriage that puts shared roadmaps, shared benchmarks, and shared code repos on the table. Roboverse itself is worth a minute of airtime. Under the hood, it is a 3-piece toolchain, a full GPU-accelerated simulation platform, a synthetic data engine that cranks out weird edge case scenarios 24/7, and a unified benchmark suite so policies trained on, say, Mujoko legs or Isaac torsos get graded the same way. Reborn's own paper claims the bundle slashes raw wall clock training by about a factor of 30 compared with the vanilla PPO jobs many labs still run. Back of envelope, that turns a weekend grind into an evening compile, and Unitree's team is already seeing that jump in their internal numbers. Now, the open source angle is more than lip service. Unitree and Reborn are spinning up public hackathons, releasing a steadily growing G1 motion capture dataset, and inviting outside devs to push reward tweaks or perception modules, the same way folks send pull requests to a normal GitHub project. For a company that sells hardware at scale, loosening the control loop looks risky, but the upside is obvious. More people experimenting means more behaviors discovered and ultimately more robots sold. If the plan sticks, we might finally see a robotics community that shares best practices the way PyTorch users share model checkpoints. The software story does not end there because, almost in parallel, Berkeley's Youngioso dropped FastTD3, and that paper hit the reinforcement learning crowd like a cymbal crash. Keeps the plain Jane TD3 core twin critics, delayed updates, deterministic policy gradients, but then yanks every speed lever in reach. 128 parallel simulators feed a replay buffer that sits entirely on the GPU. Each gradient step chews through 32,000 transitions, and distributional critics turn Q values into full probability spreads. On a single A100, the algorithm tears through the entire 40-task humanoid bench suite in under 3 hours, then knocks out the rough terrain Isaac Lab courses and Mujoko playground joystick tracks on the same afternoon. And those are not cherry-picked demos either. Every learning curve is in the repo, along with AMP mixed precision switches, torch.compile flags, and a single file config you can copy-paste into your own project. The real kicker is that nothing in the code looks exotic. No curiosity bonuses, no fancy model-based rollouts, just raw throughput. The deterministic policy gradient's usual exploration problem disappears because the simulators spray so many diverse states back into the buffer that exploitation becomes the smartest move. As proof the numbers are not just pretty charts, the team took the policy trained in Mojoko Playground and dropped it directly onto Booster Robotics' full-size T1 humanoid. Same weights, no fine-tuning, straight into real hardware. The robot walked awkwardly at first, but without toppling, and that is the first documented off-policy sim to real transfer on a humanoid that big. It is the kind of demo that forces every lab manager to update their planning slide deck, because overnight iteration cycles are not just wishful thinking anymore. Fast iteration also shines a light on an old headache: reward design. Berkeley's team discovered that the walking reward, tuned for PPO, made FastED3 wave its arms like a windmill. They dialed up velocity penalties, retrained for 2 hours, and got a smooth gait. Then they tried those new coefficients with PPO and watched that algorithm crawl like it was knee-deep in mud. The takeaway is brutal but freeing. Different reinforcement learning recipes need different reward spices, and when your training loop is measured in hours, you can actually afford to experiment until the motion looks right. While all that code was humming on GPUs, Beijing decided to test biped bots the old-fashioned way, a half marathon on public streets. 21 humanoids lined up, only 6 finished. The one that crossed first was Tiankeng Ultra, a 1.8 meter biped from the state-backed Beijing Humanoid Robot Innovation Center, clocking a human qualifying time just under 2 hours 40. Footage showed other bots skidding, clipping railings, and overheating, but Ultra kept its balance, and Chinese media lost no time framing the run as proof of bipedal superiority for rubble-strewn disaster zones. Fresh off that win, the lab rolled out Tiankeng 2.0. The spec sheet boasts higher torque joints, a perception stack tweaked for rough terrain, and, most intriguing, native multi-robot clustering. The engineers claim squads of Tiankeng units can split up tasks on factory floors or in logistics depots, handing parcels across conveyor gaps, or supporting each other when a long sequence assembly routine needs 4 hands at once. Nobody outside the lab has benchmarked those swarm behaviors yet, but the marketing videos show half a dozen gray and orange frames weaving through a mock supermarket and restocking shelves in sync. Meanwhile, Shenzhen's Standard Robotics took the humanoid silhouette and bolted it onto wheels. Their Darwin 01 folds its torso to duck under racks, pops back up for reach, and swaps end effectors so the same chassis can grip a milk crate at noon and tighten a bolt after lunch. 10-kilogram payloads ride just fine on that Omni wheelbase, and the spec sheet claims speeds north of 2 meters per second plus 12 hours on a single battery or a hot swap sled. That is the kind of endurance that makes warehouse managers perk up, because energy-hungry biped legs rarely crack a full shift without recharging. What is striking is how all these apparently different strands, open source humanoids in Hangzhou, speed-optimized reinforcement learning in Berkeley, wheeled torsos in Shenzhen, marathon-tested bipeds in Beijing, are weaving themselves into one tapestry. Roboverse does not care whether the body below the policy walks on ankles or rolls on casters. FastED3's replay buffer stores float 32 tensors, not leg metaphors. A control loop trained on Unitree's G1 could, with a clean retrain pass, steer a Tiankeng arm or a Darwin gripper, because the underlying abstraction is just joint positions and target accelerations. That portability is what the open source hackathons are betting on: shared data, shared code, and hardware diversity, instead of one vendor per ecosystem. Zooming out, the money folks smell a bonanza. Market analysts who used to treat humanoids as a science fiction sideshow now predict a jump from just under $3 billion in 2025 to more than $15 billion by 2030, a compound pop of almost 40% a year, and that is the conservative forecast. NVIDIA's Jensen Huang went one louder at Consumer Electronics Show, calling robotics a multi-trillion-dollar Peace Prize, while he unveiled new AI models aimed exactly at training and deploying bots like these. If the semiconductor guys think the upside is that high, it is a fair bet the venture crowd will keep pouring capital into every demo that looks halfway stable. So here is the question. If robots can already run a half marathon, train themselves overnight, and restock shelves faster than a human, what exactly will be left for us to do in 5 years? Will we be managing fleets, collaborating as equals, or just trying to stay relevant? If this gave you something to think about, or if you are just here to keep up with the robot revolution, make sure to hit like, subscribe, and drop your thoughts in the comments. Thanks for watching, and I will see you in the next one.